Despite creating the wallet object first, in this wallet directory, we still have yet to write a specific test for this class. The primary reason for waiting a little while to write the wallet test was that there wasn't anything very significant to test previously, since the wallet consisted simply of its initial balance, a key pair, public key, and a sign function, which we tested through checking that our signature verification function works properly, which depends on there being a signature in the first place. However, now that there is the create transaction function, we have enough logic in the wallet class to warrant a test. So let's create a new index.test.js file, which will test the default index.js wallet file that we have. So in the wallet directory, let's make a new file called index.test.js. The goal with this testing file will be to check if the create transaction method indeed adds and updates transactions to and within the given transaction pool. Therefore, we'll need the wallet class itself first of all. So let's grab the wallet so that way we can actually test on it. But likewise, we'll also have a dependency on the transaction pool so that way we can pass it in to the create transaction method, since the transaction pool instance is the final parameter to the create transaction method. Now we'll capture all the tests with an overall describe block that describes this test as the wallet test. For each following test, we'll want there to be a wallet instance and a TP variable that we can use, and TP is short for transaction pool. Before each following test, let's assign each of these variables to their respective instances of the class. So we'll make a wallet, a new wallet instance of the wallet class, and TP is a new transaction pool instance. And then we'll start writing the narrative for this test. First, we'll describe a situation where the wallet is creating a transaction. So let's describe the situation where the wallet is creating a transaction with the describe block. And here's our arrow function second parameter. When creating a transaction, we'll want a variable for the transaction itself, and also a send amount and recipient variable so that we can check that the transactions are truly created for the amount that we specify with the given recipient. So we'll have transaction, send amount, and recipient variable for each following test. This allows us to create a transaction for the recipient with each send amount before any following test. So we'll set the amount before each test to an arbitrary value. So we'll have a before each block, and first up we'll set the send amount to something like 50. Then we'll assign the recipient to something also arbitrary. So how about the leet speak version of random address R4ND 0M-4DDR355. Kind of looks like random address if you try really hard. And then the transaction equals wallet.create transaction. So now we're creating a transaction with the new wallet create transaction function. And then the parameters we're providing are the recipient to send to, the send amount that we're sending with, and then lastly, the transaction pool object that the create transaction function will add the newly generated transaction to. All right, this creates a transaction and adds it to the given pool. The logic that we want to test is, well, what happens when we redo the same transaction? If we redo the same transaction, well, we'd hope that the function sees that the transaction already exists in the pool. Therefore, it will update the transaction with an additional output for the recipient of the transaction. And likewise, it should double the amount subtracted from the original user's balance if that send amount is indeed the same in both the original transaction and the updated transaction. So let's capture this in a scenario now that is again wrapped in the describe block. And in this case, we're going to describe a situation that says, and doing the same transaction. So in this describe block, we're going to repeat the same transaction. So before any following test in this block, we're going to have our before each block again. And in this case, we'll take the same code as above and redo the transaction by creating wallet.create transaction. And then given the same recipient, as well as the same send amount, and then the same transaction pool instance. So this will repeat the same transaction that created the original transaction object over here within the describe block that is doing the same transaction. All right, now we can write an actual test. For the first test, we'll make sure that it doubles the send amount that is subtracted from the wallet balance. So it doubles the send amount. Notice the use of backticks to indicate that send amount is a variable subtracted from the wallet balance, and that is the whole message. Then we have the callback function in here. In this test, we'll look for the output within the transaction whose address matches the public key of the wallet, which in this case is acting as the sender wallet. We'll look at its amount and we'll expect it to equal the wallet balance minus the send amount times 2. So first up, we're going to look through the transaction's output objects, and then we're going to find the output object whose output.address matches the wallet.public key. So this will return the output object that is designated for the wallet as the resulting transaction amount. And then we're going to access the amount of this found object, and then we'll expect that to equal the wallet's balance. So wallet.balance minus send amount times 2. Since after all, by the time we get to this test, the transaction has been performed twice. So again, find the output whose address matches the wallet public key, access its amount, and then expect that to equal the wallet balance minus send amount times 2. Next, we'll have one more test which proves that the send amount output object for the recipient was created twice since we repeated the transaction. So this test will say that, well, it clones the send amount output, again, the backticks to designate that send amount is a variable, output for the recipient. So we should find two matching output objects consisting of the send amount within the transaction. So here we have our callback function. In this test, we'll filter down the outputs to only those whose address matches the recipient, and then we'll look at its amounts, because we'll expect there to be two of them to match the two transactions that we created to send the send amount to the recipient. So we'll expect that if we filter down the output objects of the transactions using transaction.outputs.filter, we're going to look at one object at a time, so one output object at a time, and then we'll only return those whose output.address is equal to this recipient. Now we only want an array of the send amounts, so we're going to use the map function now. So call .map, and then we're going to map all the output amounts. So the result of calling map on the individual output object and send output amount is to take the entire output object and then transform the array to a new one that only consists of those amount numbers. So again, this overall filtering accomplishes making sure we only look at output objects whose address match the recipient. And then the map function creates an array of those output amounts. All right, so what do we expect this to equal? Well, we expect this to equal an array of two send amounts to match the two transactions we have created by the time that we get to this test. All right, excellent. With that, we've written a test that captures a situation where a user repeats the same transaction. By building tests around this circumstance, we can prove that the createTransaction function recognizes the existence of the original transaction within the pool, and therefore chooses to update the transaction the second time around. Overall, this captures testing the logic of the createTransaction function within the wallet. So let's now go to the command line and test this out with the npm run test script. So back in the command line, let's run npm run test. And as we do so, it runs all the tests. All right, in this case, looks like one of my tests failed. Well, turns out I have a typo when I'm mapping out the address. Notice that there's only one D. You probably caught that and were saying to the screen, oh no, there's a little typo, but not to worry, we can add a D over here and then resave the file and then open back the command line. So if you typed it out as 1D, go ahead and add that, and then head back to the command line now. And then when we save, the test reruns. So we can see that in action by pressing A to run all tests. And as we do so, we should get a fully passing test suite if all goes well. All right, perfect. Indeed, they do. The test pass, proving that the create transaction function is reliable. Now that we have a system where wallets can generate and update transactions within a transaction pool, let's extend this by including the transaction pool within our peer-to-peer server. By using the transaction pool in the peer-to-peer server, we'll truly have multiple users of one transaction pool that is updated and shared in real time across the members of the blockchain-based cryptocurrency network.